Greetings to all. This is Mrs. Sunita TC, Selection Grade Lecturer in Electronics and Communication Department, Government Polytechnic, Srirangapatana. Welcome to ARM Controller. Before starting today's session, let's just recap the previous session's topics. In the previous session, we had discussed the embedded hardware and AMBA protocol. In embedded hardware, any typical embedded device consists of processor, controllers, peripherals, and the bus. AMBA protocol or Advanced Microcontroller Bus Architecture is the on-chip bus architecture to connect the core and the on-chip peripherals. We also discussed the various features of AMBA and the reasons for its popularity. In today's session, we'll discuss the role of software components in embedded systems and applications of ARM processor. Role of software components. Any embedded system requires software to drive it. The figure shows the 4 typical software components required to control the embedded system. So these are the initialization software, the device driver, the operating system, and the application software. Here, each software component uses a higher level of abstraction to separate the code from the hardware device. So you can see right next to the hardware device, we have the initialization and device drivers. That is, these two softwares closely interact with the particular hardware device. They are target specific. Whereas the operating system is placed above the initialization layer and the device driver layer. So operating system has the option to either directly interact with the hardware device or, as is usually done, through the device driver software. And we can observe that the application layer or application software is placed above the operating system. There is no way the application can directly interact with the hardware device. It has to communicate through the operating system with the hardware device. So you can see the farther away the layers are placed from the hardware device, higher is the level of abstraction which will separate that code from the hardware device. The initialization layer or code is the first code which will be executed on a board, and this layer is specific to a target or group of targets. So whatever particular device you use, so its features, its characteristics must be known to this code, and accordingly it will initialize that target hardware. So this is also known as boot code, and this boot code, when it is run, it takes the processor from the reset state to operating state, and it also readies all the hardware devices on the system and brings them into the active state. The initialization code usually works in three phases, or the task can be organized into three different groups: initial hardware configuration, diagnostics, and booting. So the initial hardware configuration sets up the target platform so that an image can be booted. That is, the OS resides in the ROM or flash ROM memory, and when it is operating from this ROM area, it takes up lot of time. Suppose this resides on the RAM, then considerable speed of operation can be achieved. So, systems have a method where initially the operating system runs from the ROM region, and one of the first tasks that is done by the OS will be to load a image of itself onto the RAM area and transfer the control to that image. So that from there on, the image OS will take control and operate the hardware. This will significantly improve the operating speed. So the other task that the initial hardware configuration piece of software does is it takes the processor from reset state to the operating state where the OS can run, and it also configures memory controller, processor cache, and the other hardware devices and initializes them. Diagnostics are often found embedded inside the initialization code. So it is a testing software. It tests the system by exercising or operating the hardware to check if the target is in working order. So when a diagnostic code is run, its primary purpose is to identify if there is any fault and isolate that fault. So the next topic is booting. Booting is loading an image and handing over the control to the image. So when the image of the OS is loaded, the entire program, including the code and data, may be loaded into the RAM, or just a copy of data area containing volatile variables may be loaded into the RAM. So once it is booted, the system hands over the control by modifying the program counter to point into the start of the image. So that is, the control is transferred to the image. The next software layer is device drivers. Again, this is the layer which is placed right next to the hardware devices, and this is also target specific. It is written for particular devices. So this device driver software, it provides a consistent software interface to the peripherals. It is through this layer you can interact with the hardware device. And that is the normal way in which the operating system interacts with the hardware. The operating system. The initialization process prepares hardware so that an operating system can take the control. The function of the operating system is to organize and manage hardware system resources like peripherals, memory, and processing time. The ARM processors support over 50 different operating systems. Generally, there are two classes of operating systems that are used in embedded systems: the real-time operating systems and the platform operating system. Real-time operating system. In real-time operating systems, it is required that there is a guaranteed response time to events. That is, whenever an event occurs, the response should come within the specified time. So there are two categories of applications for this real-time operating system. One is known as the hard real-time applications and the other is the soft real-time application. In hard real-time applications, a guaranteed response is necessary to work at all, else there will be a fatal error and the system will not work. Whereas in case of soft real-time application, a considerably good response time is essential for the system to perform its task. If there is a delay, it may be acceptable and it may take appropriate action and continue with its functioning. Whereas in case of hard real-time applications, if there is no response, a fatal error will occur. Generally, the RTOS systems are designed so that they do not have secondary storage. So this is because having a secondary storage device means that there may be some delay in memory access, or it may take more time to complete the memory access in case of secondary storage. So usually the RTOS systems avoid the usage of secondary storage. So example of RTOS OS is Vertex. The other class of operating systems normally found in embedded systems are the platform operating systems. So these have a memory management unit to manage the non-real-time applications, and they also have secondary storage. So example, Linux. Many embedded systems may not require a full operating system at all. So they do not need either RTOS or platform operating systems. They simply need a very simple task scheduler which is going to allocate the series of tasks which should be done in a sequential manner, and this could also be implemented in two ways. That is, the task scheduler can be implemented in two ways. Either it may be poll driven or event driven. Poll driven means the task scheduler simply performs a poll, and if there is a response, it will take action or conduct that event. In case of event driven, the occurrence of an event will cause the task scheduler to perform some tasks. So this is about the various software components that are seen in embedded system. We come to the last topics of this session, that is applications of ARM processor. So ARM processor is a very widely used processor and it is used in numerous fields of applications such as networking, automotive electronics, mobile phones, consumer devices, mass storage devices, imaging, and many more. And within each of these segments, the ARM processor is used in multiple applications. The list of the applications is endless. Still, we select some important applications and discuss them. ARM processor is widely used in networking applications like home gateways, DSL modems, high-speed internet communication, 802.11 standard wireless communication, and others. Another popular field of application of ARM processor is in portable devices. So as ARM-based embedded systems are very small in area and give a very small form factor, they are quite popular in the portable devices like mobile phones, PDA, personal digital assistant, laptops. Cellular phone is one of the largest applications of ARM processor. Strong ARM, one of the variants of the ARM core, is designed for use in mobile phones. ARM is also used in mass storage devices like hard drives. They are used in imaging products like inkjet printers. The automobile segment is another major field where ARM processors are widely used. Here, a high-end car may have as many as 30 to 40 microcontroller based embedded systems in it. Some of the embedded systems found in cars or vehicles are for fuel monitoring, ABS, anti-braking system, air conditioners, and so on. Another important application field for ARM controllers is the consumer electronic devices or white goods like washing machine, microwave oven, Xerox machine, MP3 players, DVD players, iPods, TV, set-top box, TV remote, all have embedded systems in them. With this, we conclude our session. Some of the descriptive questions on this unit are: explain the role of software components in an embedded system. List the applications of ARM processor. Explain the functions performed by initialization code. What are the types of operating systems used in an embedded system? Few questions with one-word answers. The four typical software components required in an embedded device are initialization, device driver, operating system, and application. During initialization, the three tasks that occur are initial hardware configuration, booting, and diagnostics. Dash code tests the system to check if the target is in working order. The diagnostics code checks if the target is in working order. The primary purpose of diagnostic code is fault identification. An OS organizes and manages system resources such as memory and peripherals. Operating system is classified into two main categories: platform operating system, and RTOS or real-time operating system. Embedded applications may be classified as soft real-time application and hard real-time applications. Systems running on real-time operating system generally do not have secondary storage. ARM-based embedded systems usually have low power requirements. Dash software performs task-specific duties of an embedded system. The application software performs task-specific duties in an embedded system. With this, we conclude the session. These were the references that were utilized in preparing the material. Thank you.